Hello, this is Frank Allen's chemistry class at Davis High School, Aldine School District. Today's video is going to cover an initial introduction to the topic of radiation and radioactivity. So we've all heard the word radiation before. We may have seen something about it in the news or in movies or something like that. Radiation is the spontaneous decay of a nucleus. That's why we generally call this nuclear chemistry. We're dealing with the nucleus of an atom. Spontaneous because we don't know when the atom's going to decay. And so radiation is a process, but we also refer to it as a noun. It's actually things that an atom gives off. So how does a particular atom decay? Well, the nucleus will emit or give off particles and or energy, or both, until it is stable. Why do we have radiation? Well, we have radiation because the nucleus is unstable, sometimes. Most nucleuses are not unstable, they're stable. They're quite happy the way they are, but sometimes they're unstable. And what is radiation, or what are the kinds of radiation? There are three types of radiation: alpha radiation, beta radiation, and gamma radiation. On a quiz, you would have to be able to tell me the definition of radiation, which is the decay of a nucleus, and you would have to be able to answer the how and the why. The how: does it decay? The nucleus will get rid of some particles or energy until it's stable. That's sort of the important part. We'll go over some specific things with the three types of radiation here in a second. Now, the three types of radiation, as we said, are alpha radiation, beta radiation, and gamma radiation. Alpha radiation is 2 protons and 2 neutrons. So a nucleus that is undergoing alpha radiation is going to emit some particles, and the particles that it will emit are 2 protons and 2 neutrons. A beta particle is an electron. And so the nucleus will emit, in beta radiation, an electron. Gamma radiation is simply a piece of energy. It's not really a particle. You do have to know something about the three types of radiation. Alpha radiation, because these are protons and neutrons, they're bigger than electrons. So this alpha particle is a lot bigger than a beta particle. And of course, gamma is not a particle. So alpha is big, beta is smaller, gamma is an energy. It's not really a particle at all. Alpha particles can't penetrate very many things. They do not penetrate very well anything, so they can't even go through paper. Beta particles can go through paper. They can't go through clothing, skin probably. Gamma rays can penetrate a lot of things, but once they get to very thick things like lead and concrete, very dense substances, then they don't penetrate those. So alpha doesn't penetrate much. Beta penetrates a little bit more. Gamma can penetrate lots of things except for very dense substances like lead and concrete. Alpha, because it's big, causes the most damage if it gets inside of us. Beta, it's a little bit smaller, so it causes some damage, but not as much. And gamma is a lot smaller, and it doesn't cause as much damage either. One of the things you'll be required to show me is a diagram of radiation. This just represents some atom. It doesn't matter what shape you use. It doesn't matter what figure or symbol you use. If you have an original atom, it's going to give off some radiation, whether it's alpha, beta, or gamma. You don't have to tell me which one, and you're going to have a new atom. So you start out with an original atom, gives off some radiation, you get a new atom. Note, this is a common mistake. Notice the difference between the two. Here you're combining the two and getting one thing. Here, you're giving off the two. This is a decomposition reaction. This is a synthesis reaction. That's wrong. Radiation is decay, and that's decomposition. Sometimes the new nucleus is not stable. Sometimes it is stable. If it is unstable, it will undergo radiation again. And it will keep undergoing radiation again and again and again until it becomes stable. That's the goal of every atom. It's to become stable, or as we sometimes say in class, happy. Now you're going to have to show, in addition to sketching a diagram, you're going to have to show some general chemical equations of irradiation. And so you would start with uranium-238 or some element, some isotope that I give you. You could remember that isotopes are simply atoms that have a different number of neutrons. So these are two isotopes of uranium, and I would specify if I wanted you to show me alpha or if I wanted you to show beta. We won't have to show gamma. So uranium-238, mass number goes up here. You look on the periodic table for uranium. I said you look on the periodic table for uranium. It's got 92 protons. So it has 238 nuclear particles, 92 of them are protons. It's going to give off an alpha particle. Now this is an alpha particle because it's 2 protons and 2 neutrons. 2 protons makes it helium, and the fact that it's got 2 protons and 2 neutrons means that it has 4 nuclear or mass particles. And you have to tell me what's left. Look at this for a second, make sure you understand where I'm getting these numbers. This is just like an equation. 92 is equal to 2 plus 90. This is the new atom. If it's radioactive, it'll undergo radiation again. If you were going to show me uranium-235, it's going to look pretty much the same. And of course we know that this is thorium because number 90 up there on the periodic table is TH. If you were showing calcium, you might want to stop the video right now, stop it and practice this one and then turn the video back on. If you were showing calcium, this is what it would look like. And you don't have to put the radioactive particle first. You could put the new atom first and then the radioactive particle. It doesn't really matter. And 18 is going to be argon. So that would be alpha radiation. Beta. Here's something you have to know about beta. We said earlier that beta is an electron that gets kicked out of the nucleus. Well, how can an electron get kicked out of the nucleus? There aren't any electrons in the nucleus. Well, beta actually occurs when a neutron breaks apart into an electron and a proton. And this is negative and this is positive, so if you combine the two together, you get something that's neutral. So that should be fairly intuitive and easy to understand. For some reason, a neutron will break apart and it's going to get rid of an electron. The proton stays inside the nucleus, but the electron gets kicked out. So it's going to be the same. We get all this information from the periodic table. That's all, 23. There's different sodium atoms. Some sodium atoms have 22 mass particles, some have 23 mass particles. It's going to get rid of an electron. Now what's an electron going to look like? Well, this is what a beta particle looks like. It's got 0 mass particles or 0 things in the nucleus, and we use a -1 to represent its charge, so to speak. So 23 minus 0 gives you 23. 11 minus a -1 gives you 12. Be very careful here. Notice that your number of protons increased by 1. Here your number of protons decreased by 2. So make sure that you're reading this left to right. This is equal to this plus this. Carbon 14. Beta particle. Original atom, new atom. And again, if these are radioactive, they'll undergo further radiation until they're stable and they're happy. So beta particle occurs when a neutron breaks apart into an electron and a proton. The electron gets kicked out, the proton stays in there. Alpha radiation occurs when the nucleus just decides, hey, I don't like the number of protons and neutrons I've got to do something about it, so I'm going to get rid of 2 protons and I'm going to get rid of 2 neutrons. Essentially, that is a helium particle, and that is your radiation. These things are all around us. Radiation occurs naturally. Humans can sort of create our own radiation for whatever purposes we want, but there is radiation hitting your body as we speak. There's just not enough of it to cause any damage. If we have a large amount of radiation that starts hitting us, then it possibly could cause some damage, but it causes the most damage when we ingest it. And we ingest it either by eating it or by breathing it in. So when there's a large amount of radiation, such as a radiation leak in Chernobyl or Japan, one of the dangers is that you can't really inhabit the area where the leak occurred because you would be breathing in radiation and possibly ingesting radiation, and that is what causes damage. Now, there are 2 ways that radiation is harmful to us or any other organism. It can damage DNA, and when a cell with damaged DNA replicates itself, it usually results in a bad cell that doesn't work properly, multiplies fast, and that essentially, basically, is what cancer is. Our cells are always having to fight changes and mutations to DNA, and most of the time they catch it, but sometimes they don't. It can also damage organs. This just gives us radiation sickness. So if we were to be hit with a lot of radiation all at one time, it's not as though we're going to get cancer overnight, but it will cause radiation sickness. Radiation, however, is useful because just like it can damage cells, well, we can use radiation and target it to cancer cells to kill them. We also use radiation to kill bacteria on our food. A lot of our food has been cleaned, so to speak, by using radioisotopes to kill bacteria on the food. We can also use radiation to help us take images of inside the body. If you've ever had a CAT scan, an MRI scan, a CTI scan, a lot of that is radiation. So that's the introductory lesson. You might want to go back and look at this and view it again. Make sure that you can answer the particular questions. Define, tell me some things about alpha and beta radiation. Sketch a diagram. Be able to show me alpha and beta radiation there. If I give you the particle that I want you to show, I would give you the particle. And then tell me how it's harmful and tell me how it's useful. See you in class.